Okay, working on the review. So I know that it's labeled incorrectly. It's actually part C. I'll just change that now. It's part C. And so on part B, it said consider the sequence. So we had x minus 3, x plus 1, and then 2x plus 8. And it was pretty simple. We plugged in a 5 in here and then just verified that it was, in fact, a geometric sequence. In this one, it says find the other value of x for which the sequence is geometric. And so let's think about that. Here's the work from before. We need to find some relationship between the different values that we have in our sequence. And we know that the common ratio, if I divide, for instance, u2 divided by u1, I get this ratio, right? And then if I divide u3 and u2, I get that ratio, and they're equal to each other. So we could say that r equals x plus 1, which is our u sub 2, divided by x minus 3. But r also equals 2x plus 8 divided by u2, which is x plus 1. Now, since they're equal to each other, we can set them equal to each other. And we get x plus 1 over x minus 3 equals 2x plus 8 all over x plus 1. And it's interesting. You could see that we have this geometric mean happening. I think that if you remember in your geometry class, we have this formula that comes out and we're working with proportions where this number here is equal to that number there, and then these are the extremes, right? So that's kind of interesting. Just a little extra thing that I was noticing when I was working on it just now. I was like, oh, hey, look at that. That's kind of neat. And so, let's see. Let's go ahead and solve this. I don't see any cancellations. I can see I pull out a 2 here. That's not going to really help me. So I don't think it will. Let me see. Yeah, no, that's going to give me a 4. That's not going to really help me at all. So I'm just going to go ahead and multiply this to the other side. So this is x plus 1, x plus 1. All right, I'm just multiplying this side by x plus 1 and that side by x plus 1. That's going to cancel out. And then I'm going to multiply by x minus 3 to bring it onto the other side. So 2x plus 8. Okay, x minus 3. Now I'm just going to combine, or we're going to FOIL here. So x times x is x squared. X times 1 is x. Then again, x is going to be plus 2x plus 1 equals, let's go this way. We have, here I'll multiply it this way, so that's the way I want to look at it. If because this has a 2 in front of it, I don't want to really deal with it that way. So I'm going to go this way. So 2x squared plus 8x minus 6x minus 24. Great, and this now combined like terms. I could see that the highest power term is on this side, and it has the the term with the highest power and the highest coefficients on this side. So I'm going to bring everything this way to make my life easier. And so I'm going to bring my x over to the other side, and I'm going to get a x squared, because 2x squared minus x squared is x squared. And then I'm going to bring this one over, and then I'm going to get plus 6x. I'm going to bring this over, and I'm going to get a negative 25, and I'm just going to drop this down. Well, isn't that fortunate? These two cancel out. Okay, minus 25. Okay, and that, of course, equals 0. So in this case, we have x squared minus 25, and hopefully you're seeing that we have a difference of 2 squares here. Let me just write it out. This is x squared minus 5 squared, right? And so that's going to become an x plus 5, x minus 5. Okay. So the two values that we get are x equals 5 and x equals negative 5. Not bad. Now, we've already worked with this x equals 5 from before. See, that's where that came from. So the other value would be this negative 5 here. Okay. Oh, so here we go. So find the other value of x. All right, so we know that. And then for this value of x, find the common ratio. Well, we can do that. That's fine. So if we know that x equals a minus 5, and that's what we're going to go with here, we can go ahead and plug it back into our original sequence. So let's just go ahead and make a table. I'm going to make a table right here. And this is our n values and u. Okay. And so the first term, I'm going to plug in a negative 5 in for x, and I'm going to get negative 5 minus 3, so negative 5 minus 3 equals negative 8. Second term, I'm going to plug a negative 5 in for x, so I get negative 5 plus 1, and that equals a negative 4. And that last term, I get 2 times a negative 5 plus 8. Okay, and that's going to equal negative 10 plus 8, which of course equals negative 2. Okay. So we need to find our common ratio. And so R equals R2 divided by R1. So R equals, U2, I misspoke. U2 divided by U1. So U2 divided by U1, which is negative 4 divided by a negative 8, which equals positive 1/2. And let's see if that holds true for the next one. And so I'm going to take U3 divided by U2, and I'm going to get a negative 2 divided by a negative 4. Hey, look at that. And that equals 1/2. So we are done. We know that our common ratio equals 1/2. And there we go. Not bad.